All right, guys, let's get rolling. All right, so this is sort of a take on the problems that we did yesterday, where notice that in terms of degrees, this is not a reduced fraction. Okay, so the degrees are the same, so we've got to do the long division. Now, if we're lucky enough, okay, this is not reduced in terms of binomial factors. So clearly, I would always check that. Okay, so if we take a look at, what would this guy look like if we factored both the numerator and denominator, and maybe we get a binomial, a common binomial factor that we can cancel off. Okay, so down below, I've got a 2x and an x, and let's see, that would have to be plus 5 here and minus 1 there. Okay, good, that'll give us a 9x. And then if we look up above, okay, 3x and an x, let's see, that would have to be a plus 2 here and a plus 1 there. And obviously there are no binomial factors that are common, so we can't, factor those guys out and reduce it down. So we're stuck with what we got. So we have to do the long division. Okay, so if I go 2x squared plus 9x minus 5 and divide that into the numerator, 3x squared plus 7x plus 2. So we go 3x squared divided by 2x squared, and obviously you get 3 halves. Okay, and then we multiply through, so 3 halves times 2 is 3x squared. Okay, let's see, 3 halves times the 9, that would give me 27 halves, so I got plus 27 halves x. And let's see, negative 5 times the 3 halves would give us negative 15 halves. And then we got to subtract everything. And obviously, let's see, this guy goes away. Okay, and let's see, this would be 14 halves minus 27 halves, so that'd be a negative 13 halves x. And let's see, this would be 2 minus a negative, so that'd be 2 plus 15 halves. So that would be 4 halves plus, right, that would be 19 halves. Okay. All right, so let's see, obviously you can't keep going, there's nothing to bring down. And obviously when you do if you try to divide this by this, obviously this has a higher degree than this, so you would get x down in the denominator, which we don't want. Okay, so let's see, so this guy right here, okay, I would have 3 halves plus my remainder, negative 13 halves x plus 19 halves, all over the divisor, okay, which is 2x, well, and I'm going to write it like this. I'm going to write it like in factored form. That's my 2x minus 1 and x plus 5, okay, like that, dx. Okay. All right, so it's this portion right here that I have to deal with in terms of using partial fractions. Okay, so I got to deal with that guy. So let's see what we got. Okay, so I've got my negative 13 halves x plus 19 halves, and that's all over my 2x minus 1 and my x plus 5. And that has to be equal to some constant over 2x minus 1 plus some constant over x plus 5. Okay, so if we take this whole thing and multiply through by this guy, okay, it'll get rid of all the denominators and get rid of the fractions then. Okay, so I multiply through by 2x minus 1 and x plus 5. Okay, so let's see, all these cancel with those. All right, so I get a negative 13 halves x plus 19 halves equals, let's see, it would be a, that 2x minus 1 cancels there, so it would be a times x plus 5 plus, let's see, here the x plus 5s would cancel, so I'd get b times 2x minus 1. Okay. And so we are going to do the same thing we did yesterday. Okay, so let's see. If I want to get this guy to cancel off, I'd have to let x be negative 5. Okay, so when x is negative 5. Okay. All right, now the good thing about here is I did this morning and it works out. So we've got to put negative 5 in here. Okay, we got to put negative 5 in here, and we got to put negative 5 in here. Okay, so you pick up your calculator and you just evaluate this when x equals negative 5. Okay, and you end up with 42. And you're more than welcome to check that. Okay, when you put negative 5 in here, we're going to get 0, so you get a times 0. And when we put negative 5 in here, that would be negative 10 minus 1, so it'd be negative 11. So b is negative 11. Okay, so obviously this guy goes away, and then you just divide both sides by negative 11, so b ends up being 42 over negative 11. Okay, all right, so right here, we have to make this a 0. Okay, so that is going to happen when x is equal to 1/2. Okay, so let's see, again, you got to go over here and evaluate, and I did this morning. And when you punch in 1/2 there, you can check it on your calculator. I'm going to get 25/4 over here on the left-hand side. Equals, let's see, when I put 1/2 in here, well, that'd give me 1/2 plus 5 is 5.5 or 11/2. Okay, so that's a times 11/2 plus b. When I put 1/2 in here, I get 0. Okay, so this goes away. Okay, and let's see, I would have to take the 25/4 and divide by 11/2. Okay, so my a is going to be at 25 over 22. Okay. Okay, all right. Now I went back this morning and I checked this just to make sure. Okay, so I went back to this guy right here, and you can do this on your own if you want to. Okay, and I put the 25 over 22 here, and I put the negative 42/11 here, okay, and I found a common denominator and add them together, and you do get this right here. So I was, I wanted to check just to make sure, okay, so I went back and did that, and this is correct. It does work out. Okay, so let's see, let's take what we have, and let's see what we got going on here. Okay, so let's see. All right, here's what I'm looking at. Okay, so I'm going to have the integral of 3/2 dx plus the integral of, remember I split this up right here, okay, and I got that guy right here. Okay, so the first one is going to be a over 2x minus 1, okay, and then the other guy is going to be b over x plus 5, okay, and so let me get my a and b. So let's see, my a is 25 over 22, so that 25 over 22 goes here, okay, and my b is negative 42/11, so that goes there. Okay, so I got everything set up, so we're good to go. Okay, so let's see what we got going on here. Okay, when I integrate this guy, obviously I'm just going to get 3/2 x. Okay, and let's see. I'm going to integrate both of these one at a time, obviously, so I'm going to take that 25 over 22, put it out front as a constant multiplier. 1 over 2x minus 1 dx. Okay, I'm going to bring this guy again, I'm going to bring him out front, so it's going to be minus 42/11 times the integral of 1 over x plus 5 dx. Okay, so let's see, this guy is done, so he's just coming along for the ride. Okay, so let's see, this guy I would have to let u be 2x minus 1 which means that du is 2dx, so I get 1/2 du equals dx. Okay. All right, so this will give me, I probably should have moved this guy down a little bit. Let me move him down a little bit more. Okay, I don't want to lose him. You know how I am about that stuff. Okay, so 3/2 x. Okay, plus, let's see, I've got the 25 over 22. Okay, and let's see, I've got the integral. This would be 1 over u times 1/2 du. Okay. All right, minus, let's see, this is going to be 42 over 11. And here I would let u be x plus 5. So my du is dx. Okay. So we just get, let's see, 1 over u du. All right. So far, so good. Okay, so let's see, this 1/2 goes out front as a constant multiplier, and so I multiply it by the 25 over 22. So I'm going to get 25 over 44, okay, and then I would get the natural log of u, okay, so that would give me the natural log of u, which is 2x minus 1. Okay. Minus, let's see, this 42 over 11, this would be the natural log of u when I integrate it, so it would be the natural log of x plus 5. Plus my constant of integration. Okay, and I'm looking at that guy, and I am thinking, notice that there's no way to factor out a GCF to just get this guy and this guy by themselves, where I could use the quotient rule. So I'm going to leave it in that form. Okay, I'm going to go with that. Now, if you wanted to, you could find a common denominator. If you wanted to, okay, and you know, I mean, we'll take a look at it. I don't know if it makes that much of a difference. Okay, so let's see, a 2, a 44, and an 11, so it'd have to be 88. Okay, which means I'd have to multiply here by, what, 44? Okay, so 44 times 3, 132, so that'd be 132x. Let's see, right here I'd have to multiply by 2, so that would be, what, a 50 natural log of 2x minus 1. Here I'd have to multiply by 8, so 8 times 42, 8 times 42, 336 natural log of x plus 5, and then plus your constant of integration. You could go that route if you wanted to. Let me check and see if that is good. Let's see. Wait a minute. I could have just gone with a 44, couldn't I have? All right. What am I thinking, 88? Let's go with a 44. Yeah. How about we just do that? Okay, so that'll change this guy. That'll change this guy. That'll change this guy. Okay. I'm glad I caught that. Hopefully you guys caught it. Okay, so here I'd have to multiply by 22. Okay, so 3 times 22, so I'm just going to get a 66x. Okay, 66x. Okay. Here, nothing changes, so that's just 25. Okay, and here I'd have to multiply by 4. 168. Okay. Well, numbers are a little bit smaller. Okay. Well, was that a bonehead mistake? Okay. Let's see. Glad I caught it. All right. So, I mean, I would just go with this answer right here. Okay. I think that one, I don't think there's anything wrong with it. I don't know if I would really bother to do this, but if you wanted to, you could, and it's not that big of a deal to do, assuming you don't make a bonehead mistake like me. Okay. I would just go with this guy. I'm fine with that. Okay. All right. You guys stay safe out there, and I miss you a whole bunch, and we'll take up with some more problems next week.